Okay, so in part 3b, I'm going to look at the second part of this. We're going to solve rational equations with variables in the denominator, so we're still working on this. But this time, you're going to notice that we have variables in both the numerator and denominator of one of the rational expressions. So in the previous lesson, all of these numerators were real numbers. Now we have a variable expression. But again, as before, first thing you want to do is factor your denominators. First step is to factor your denominators. This is a rational equation. It is not linear, partly because, for one thing, there are variables in the denominator, and also if none of the variables were in the denominator, let's say they were all real numbers, and this x squared minus 1 was in one of the numerators, then that would be quadratic. So that's something that you discussed towards the end of the course last semester, solving quadratic equations. But let's see what happens here. So the first thing you want to do is to factor the denominator. So this linear factor, the GCF is 1, so there's nothing I can do there. This x minus 1, this linear factor, the GCF is 1 again. There's nothing I could do there in terms of factoring. Now over here, recall this is the difference of two squares. So I can factor this as x minus 1 times x plus 1. Okay, so let's go ahead and find the restrictions first. So the restrictions. So what is that x cannot equal? That's what you're interested in finding. So once you factor, all you got to do is set each of these factors equal to 0 and find out, well, what makes this denominator 0? This right here might be easy for all of you to determine what makes this denominator 0. So what value of x, if I plug a number into x, what number minus 1 is 0? So hopefully you said 1. And over here, if you can't determine that's negative 1, all you got to do is set this equal to 0 and then solve for x. So subtract 1 from both sides, and I get x to be negative 1. So one of your restrictions is that x cannot equal negative 1. The other restriction here, again, set that equal to 0, find out where is that equal to 0. So you add 1 to both sides, and so that denominator 0 when x equal 1. So there's your other restriction. And if you go to the next factor, that's x minus 1, well, we've already dealt with that. So that factor is going to be 0 when x is 1. And over here, x plus 1, that factor is going to be 0 when x is negative 1. So I've already taken care of that. So these are your restrictions. You have two restrictions, negative 1 and 1. Now you got to find the LCD. So remember, the LCD has to include every factor you see. Every factor you see has to be included. And you're trying to find the least. Not just any common denominator, but the least common denominator. So this factor is x plus 1. It occurs once here, none here, and once here, so you need just 1. The next factor is x minus 1. It occurs once here, 0 times here, 1 time here, so you just need 1. So the LCD is x plus 1 times x minus 1. Just as before, once you find the LCD, you got to multiply both sides of this rational equation by the LCD. The whole purpose is to clear those denominators. At some point, you want to see a 1 down here. You want to see a 1 down here. You want to see a 1 down here in the denominator. Now, remember, since these are two fractions, you're going to put that in parentheses because all of these fractions, all of them, have to be multiplied by the LCD. So we'll get the LCD, so you multiply both sides by the LCD. So the LCD is x plus 1 times x minus 1, and you can multiply that by the left side. And since these are two fractions, more than one fraction, I'm going to use parentheses or brackets, equal, and then the LCD times this side. So x plus 1 times x minus 1 times the LCD, which is a negative 2, times that fraction, which is a negative 2x divided by. Now don't rewrite as x squared minus 1. Use your factors. Rewrite it using the factorization. So it's x minus 1, x plus 1. Alright, so as before, the next step is to get rid of these brackets. So this LCD, you're going to multiply by both of these fractions. Remember, that's what you got to do. Both of these fractions have to multiply by the LCD. So we're going to get x plus 1 times x minus 1 times the LCD. Times that first fraction, minus the LCD, x plus 1 times x minus 1 times that second fraction, equal, and let's just go ahead and reduce this, so simplify this. The x minus 1's divide out, the x plus 1's divide out, and notice you do have 1 times 1, so you do have 1 in the denominator. So 1 times negative 2x is a negative 2x. So that's what I'm going to get on this side. Over here, if I reduce x plus 1's divide out, you're left with 1 times 2 times x minus 1. So remember though, just as in the previous lesson, this 1 times 2 is 2, so 2 has to be multiplied by both terms. So you can get 2 times x minus 1, leave it in parentheses just like this. Minus, over here, the x minus 1's divide out, and you get 1 times x plus 1. Again, since that's a subtraction, be on the safe side. Put that 1 times 1 is 1, so put that 1 times 1 is 1, and then 1 times x plus 1 is still x plus 1, but put it in parentheses. If you don't put in parentheses, look at what's going to happen. You're going to say this. You're going to say 2 times x plus x minus 1, and see if you say 1 times 1 is 1 and 1 times x plus 1 is itself x plus 1, just what you're going to write. And in reality, you're saying this is minus x plus 1, and it's not. It is not minus x plus 1. It is, you're subtracting x plus 1. So you got to distribute this negative 1. So what you may want to do, whenever you have a situation like this and you're a little confused, like when you have 1 times 1, put the 1 here. There's nothing wrong with that. And so 1's being multiplied by this x plus 1, just like this 2 was being multiplied by x minus 1 in parentheses. All right, and that's going to equal this negative 2x. So now, what you're going to do is you're going to distribute this 2, and you're going to distribute this negative 1. Because remember, subtracting 1 means means adding the opposite of 1. So that's the adding a negative 1. So I get 2 times x is 2x, 2 times negative 1 is a negative 2, a negative 1 times x is a negative x, and a negative 1 times a positive 1 is a negative 1, and that's equal to negative 2x. 2x minus x, combining like terms, 2x minus x is x, a negative 2 and a negative 1 is a negative 3, and that's equal to negative 2x. And what I'm going to do here, since the constant only appears on this side, I'm going to bring the variables to the right. So I'm going to subtract x from both sides, because x minus x is 0, that's what you wanted there. Adding x is not going to help, x plus x is 2x. So 0 subtract 3 is a negative 3, equal. A negative 2x and a negative 1x is a negative 3x. And then, I'm going to rewrite this over. Alright, and then to get x by itself, notice that you're multiplying by negative 3, and the opposite of multiplying by negative 3 is to divide by negative 3. Negative 3 divided by negative 3 is 1. 1 times x is x. And negative 3 divided by negative 3 is a positive 1. Alright, so my proposed solution is x equal 1. Assuming I did all this correct, x equal 1 is what I'm saying is my proposed solution. But remember, 1 is a restriction. 1 is a restriction. So 1 satisfies this linear equation right here. I mean, you can check. If x is 1, 1 minus 3 is a negative 2. A negative 2 times 1 is a negative 2. Negative 2 equals negative 2. But the problem is that my original problem was not linear. It was rational. So you got to check and see, does this proposed solution make any of my denominators 0? And it does. It makes it makes this denominator 0, because 1 minus 1 is 0. And it makes this denominator 0, because 1 minus 1 is 0, and 0 times whatever this is, 1 plus 1 is 2. 0 times 2 is still 0. So remember, this is called an extraneous root, or extraneous solution. But your answer, you're not going to write it. Don't put extraneous root as your answer. You got to tell me that there's no solution. The empty set or say no solution. So all this means is that this is a false root. It satisfies one of the equations, but not the original. Okay, that's all that says. So you got to say there's no solution. Okay, so number 2. Suppose you had negative 5 divided by x plus 3 plus 4 divided by x minus 5, and that's going to equal x plus 2 divided by x squared minus 2x minus 15. Alright, so first thing you're going to do is factor all your denominators. Again, just as before, this is a linear factor. The GCF is 1. This is a linear factor. The GCF is 1. You can't factor any of these. Now over here, this trinomial, when you factor this, that's going to be, let's see, the last sign's negative. Remember, the last sign's negative. The signs in here are different. And the larger of the outer inner will take the middle sign. So that's going to be minus 5 and then x plus 3. And you can always check, x times x is x squared. The outer is a positive 3x, the inner is a negative 5x, and when you add them up you get negative 2x. And negative 3 times positive 3 is a negative 15. Okay, so now let's find the restrictions. So again, you got to look at your denominators. So what can't x equal? Well, over here, let's look at this one. This one's easier. What value of x will make this denominator 0? So what number minus 5 is 0? Well, hopefully you said 5. And even if you didn't know that, hopefully you did though, you're in college algebra. But if you didn't, you would say x minus 5 equals 0, and then add 5 to both sides, and you get x equal 5. So that means that my solution can never be 5, because it makes this denominator 0, and I can't divide by 0. Over here, x plus 3 equals 0. So if I subtract 3 from both sides and combine like terms, I get x equal, this is 0 right here, so I get x equal negative 3. So x cannot equal negative 3. Over here, my next factor is x minus 5. I've already taken care of it. My next factor is x plus 3. I've already taken care of it. So now I've got to find the LCD. So just as before, every factor you see in your denominator has to be part of the LCD. So x plus 3 is a factor. I got to use it. It occurs once here, 0 times here, once here, so I need 1. X minus 5 occurs once here, none here, once here, I need 1. The next factor is x minus 5, I've already taken care of it. X plus 3, already taken care of it. So there's your LCD. So just like before, just like in the previous problem and problem before that, you're going to multiply both sides of this equation by the LCD. So you can say x plus 3 times x minus 5 times the left side. I'm putting the left side in parentheses because there's more than one fraction. Plus 4 divided by x minus 5 equal, and then the LCD times the other side. Now notice I'm just going to write this as x plus 2 divided by, and use the factor part, x minus 5 times x plus 3. Okay, so now remember, you're going to distribute this. You're going to get rid of these parentheses next. You can distribute. And so you're going to get x plus 3 times x minus 5 times the first fraction plus the LCD, x plus 3 times x minus 5 times the second fraction equal. All right, over here, what's going to happen is if you go ahead and reduce at this point, the x plus 3's divide out, and I've got, this should be minus 5 right here. The x plus 3's divide out, and the x minus 5's divide out, and notice what you have. You have 1 times 1 is 1, and 1 times x plus 2 is x plus 2. Remember, you want 1 in the denominator, which is what you're trying to do when you multiply both sides of an equation by the LCD, is to clear the fractions, meaning that you want to get 1 in this denominator. But 1 times 1 is 1, and 1 times x plus 2 is just x plus 2. I don't need parentheses here. It's just 1 times x plus 2 is x plus 2. Now, over here, you may say, well, you used it before. Well, yeah, but that was because I was subtracting. That's why. And so remember, we talked about that here. So if you don't use parentheses, this is, you're saying you're only subtracting x when you should be subtracting this positive 1 as well. Alright, so now let's go ahead and simplify. So the x plus 3's divide out, and notice you have negative 5 times 1 is negative 5 times x minus 5. So leave that x minus 5 in parentheses for right now. Plus, the x minus 5's divide out, and you get 4. 1 times 4 is 4 times x plus 3 equal x plus 2. Alright, so then distributing, I get negative 5x. A negative 5 times a negative 5 is a positive 25. Plus 4x. 4 times x is 4x, and 4 times 3 is a positive 12 equal x plus 2. Combining like terms, I get negative 5x and a positive 4x is a negative x. 25 and 12 is 37 equal x plus 2. All right, let's go ahead and bring the variables to the right. So I'm going to add x to both sides. So negative x and a positive x is 0. 0 plus 37 is 37. X plus x is 2x plus 2. And then subtracting 2 from both sides, I get 35 equal 2x. And then to get x by itself, I'm divide both sides by 2. And so you get x to be 35 halves. And then always check and see if that was one of your restrictions. So my proposed solution is this. I check here, it's not a restriction. So assuming that all this is correct, I didn't make any errors, then that's your solution. So my solution is x equal 35 over 2. Now, if you want to check, you can always back and substitute 35 over 2 into the original. Go back into the original, right here. And you may want to, since 35 over 2 would be a terminating decimal, you may want to rewrite as a decimal when you substitute. Okay. All right. So there's your answer here. And so all I wanted to do was to do a couple examples where you had variables in both the numerator and the denominator of one of your rational expressions. All right, so that's going to take care of this lesson where you're solving rational equations with variables in the denominator.